Okay, so let's say that we wanted to investigate an infinite series through the integral test. Okay, fine. Let's pick n equals 1 to infinity of 1 divided by n squared. All right, this is actually a very classic problem. That was around for a long time, and people tried to figure out what this series converges to. What we're going to do in class right now is we are going to justify the convergence of this infinite series, okay? We do not know what it converges to. We can just justify that it is convergent, okay? And so we're going to use the integral test, okay? Now, f of x, what would our f of x be? F of x would equal 1 divided by x squared. Is positive, continuous on the interval that we're considering. I'm not considering around 0. And f prime of x, which would equal negative 2 divided by x cubed, is less than 0. And so we can say, yeah, it's decreasing. Okay. And so the integral from 1 to infinity of 1 divided by x squared with respect to x. Okay, now this is an improper integral. We were going over this on the last test, and I would say one of the most missed problems on the last test was you didn't put a limit on this thing, okay? Whenever you have an integral from 1 to infinity, you have to put a limit on there. Okay, so this is going to equal the limit as b approaches infinity of the integral from 1 to b of 1 divided by x squared, and we're going to integrate with respect to x, right? And so that would equal the limit, now as b tends towards infinity. Okay, so if I integrate this thing, it's sitting at negative 2 right now. It's going to go up to negative 1 and divide by that. So that would be negative 1 divided by x, evaluated at 1 and at b, which would equal the limit as b tends towards infinity. That would be negative 1 divided by b, and then plus 1 divided by 1, and this portion right here would go to 0. That integral comes out to be 1. All right? So what we say is by the integral test, the sum n equals 1 to infinity of 1 divided by n squared is convergent. Okay, now this infinite series test tells you whether it's convergent or divergent. I'm looking a little off the screen for the camera. Just scoot you up a little bit. There's an important thing to notice is that, yeah, by the integral test, this infinite series, which is P series, does converge. Okay, we've shown that. It does not equal 1. Okay, so the sum I'll write it like this, but the sum n which equals 1 to infinity of 1 divided by n squared actually equals pi squared divided by 6. Okay, so the integral test does not tell us what the sum of the series is. All the integral test tells us is that if you integrate the function that is associated with the series, they are either both convergent or divergent. They are not necessarily equal. Okay, so just realize that.